Morning, everyone. It's great to be in Tel Aviv. I've been here for about a little over 24 hours and enjoying the food and the weather. It's terrific to be here. Thanks for having me here. So a little bit about myself. I'm Srinivas Sarathy. I work for TD Bank. I'll tell you a little bit about our company in a little while. I've actually just been with TD Bank for 3 months. I lead their cloud and DevOps engineering group. And I came to TD Bank from McGraw-Hill Financial, the parent company that owns Standard & Poor's. And I ran the hybrid cloud program there, which was actually based on a single vendor solution, right from the cloud management platform to the hypervisor and the infrastructure. And what attracted me to TD Bank was the open source adoption, and specifically the use of OpenStack, and the opportunity to build a best-of-breed cloud architecture. And I'm going to tell you a little bit about the architecture that we've chosen and the various parts that make that up. So firstly, to start off with, let's get a little bit of business context on what TD Bank is all about. So obviously, most of you probably heard about the company. We have about 22 million users across the globe. The business is really based on 3 fundamental product lines. The first being the retail bank in Canada and in the United States, and then being the wholesale business, the investment banking business with TD Securities. And amazing story in the last 10 years. The company has grown multifold in terms of revenue and market capitalization. Now amongst the top 10 banks in North America, counted along the same breadth as JP Morgan Chase, Bank of America, Citibank, et cetera. And obviously with all of this growth, this has had a tremendous effect on the IT footprint in the bank. So let's talk a little bit about what has happened to IT at the bank. When you have such massive innovation and growth taking place, it has come at the cost of creating a heterogeneous IT infrastructure where we have a variety of vendors, variety of different technologies, none of which allows us to be able to generate any reuse or automation. And that's happened largely as a result of a transactional focus. As you deliver multiple application projects, each with a deadline, you aren't thinking about the larger view. And so with this problem, cloud really presented an excellent opportunity for us to be able to transform the footprint. And the first step of that was to be able to standardize our technologies. And without that, it's impossible to offer automation at an enterprise scale. So the decision that we made was to simplify what we offered in the cloud. And we started to embrace what I call mature open source. So today, in our cloud platform, what we offer is a very simplified set of platforms, ranging from 2 operating systems, Linux and Windows, to JBoss as our mature open source platform, continuing to support WebSphere, which is our legacy middleware platform, and supporting a couple of databases, Oracle and SQL Server, but soon to introduce more lightweight open source database and middleware products. So the idea was to standardize the footprint to start with. Secondly, what we decided to do was to embrace a best-of-breed architecture, best-of-breed cloud architecture, and we'll talk about that. But choosing these platforms allowed us to be able to quickly develop a base set of automated products, and then secondly, be able to change the cost model. So our value proposition was, in addition to automating these services, we wanted to be able to offer it at a better price, a price that attracted our lines of businesses to be able to adopt the cloud. So let's talk a little bit about the architectural principles. The first principle really is best of breed. Instead of buying one monolithic solution that addresses all of our problems, we decided to go with a best of breed solution, ranging from the cloud management platform to the billing orchestration model, to the configuration management tool, to the hypervisor, to the infrastructure. We chose the best technologies available with the intent that as long as these technologies are open and able to integrate with each other, we could come up with a solution that could have a rapid life. We could have the opportunity to review the performance of this solution every year and make changes based on what's happening in the cloud marketplace. To have a strategy that has a life of more than 1 year is really unrealistic today with the fairly early stages of maturity in the orchestration marketplace. So that was a key principle, was best of breed. Second key principle was open source, so that we could easily debug these solutions. We could make them interoperate with each other. And standards-based. So certainly the choice of OpenStack as well as Cloudify, which I'll talk about, was to ensure that we had a mechanism that allowed applications to be ported. Today we've embraced private cloud, but there is no reason to believe that we will not have a multi-hypervisor environment in the company. And also tomorrow we will look at public clouds. As that marketplace changes and as the company becomes more prepared, public cloud becomes an option. So hybrid cloud is critical. So the ability to create an application footprint that can be easily ported across private and public footprints. So what is the architecture? Let's talk about the actual architecture itself. So the winners in this process were Cloudify, which is one of the reasons I'm here. I'm here to meet with Gigaspaces to actually look at our roadmap for the next couple of years and strengthen that partnership. And the reason we chose Cloudify was its alignment with the Tosca blueprinting standard. Secondly, we felt that this was a company that was very committed to having an open cloud orchestration model with different kinds of cloud endpoints. And so that was the attraction there. Secondly, with regards to OpenStack itself, we are operating in a managed services relationship. We chose Rackspace for a couple of reasons. One, certainly their maturity, their technical maturity in the space, but most importantly, their commitment and dedication to serving customers and their fanatical support model, which was very important to us. We are actually also going to move to Red Hat OSP and going to go to an interesting relationship with Rackspace, supporting RHEL OSP for us over the course of the next 12 months. And in order to kickstart this whole work, we built a cloud engineering team within a matter of 3 to 6 months. We now have close to about 30 engineers between Toronto and New York. Toronto being our primary location and New York being a location we chose to be able to attract talent faster. In addition to that, we went with a company called RiskFocus to help us develop a lot of these platforms and develop the integration points. So let's actually talk about probably the most interesting part of my presentation, which is the architecture. So let's start with the cloud endpoints themselves. We have 2 cloud endpoints. One is an off-premise cloud that we have in Rackspace's data center. It's a single tenant off-prem cloud, off-prem private cloud, you can say, which is designed to support dev, QA, lower environments. Essentially, we have 3 lower environments in our application lifecycle. And then we have the on-prem cloud, which is designed to support the higher environments. And we also offer a on-prem dev cloud for the purposes of latency-sensitive applications. Now, as I say this, I should mention that the scale of what we are talking about is about 4,000 applications, 30,000 servers. So this can't be a cloud only for cloud-native applications. This has to be a cloud for all kinds of applications. And I'll break them into 3 broad categories. Your cloud-native applications, next-generation web scale, mobile, web services style applications, to your second-generation, middle-class, enterprise-class applications, to even COTS applications, a lot of third-party applications that operate critical business processes. So we really need to be able to support all of these 3 types of workloads. Now, so with the 2 cloud endpoints that we have, the next key aspect here is the configuration management tool. So we've chosen SaltStack, and Salt really handles much of the automation in terms of the actual base builds for the different technologies that we have. And what drives SaltStack in our case is Cloudify. Cloudify is our orchestration tool in terms of acting as a master orchestrator and communicating between OpenStack and SaltStack. So that's essentially the simplest way of looking at this design. What you see is a lot of additional transitive technology components that we introduced in the process of introducing these 3 primary technologies. Today, we are, of course, using OpenStack as our principal cloud operating system, but we're also looking at introducing VMware as a second hypervisor into the environment. In addition to Cloudify, we use Cloud Cruiser for our billing platform. And one of the key challenges or opportunities in this model is to be able to integrate all of these solutions. And so far, we've been able to do that successfully. In addition to having these solutions, we built our own homegrown self-service portal. The idea was we wanted our own look and feel. we wanted to be able to do some integrations with our internal systems. And so we built a very simple single-page application built on Angular and running on Node.js. So that's Storm, which is our self-service portal, which also gives us a unique branding. So I think if we talk a little bit about where we are at right now, we have completed building out a dev cloud, which has about 800 VMs running on it. Since January, we have trained about 1,000 developers in writing Tosca blueprints and automating their application builds. We are soon to go into production on 8/30, and we have lined up about 30 critical applications that will be using the cloud day one. The commitment we have is that over the course of the next 5 years, majority of the new projects will adopt this cloud. And so we now have a cloud-first policy that's very aggressively implemented at the bank, which seems to be working. And I think one of the reasons it's working is because the developers find the solution very useful. They like the self-service model. They like the capability. And so it's not a hard thing necessarily to attract them to the cloud. That's not been the harder part for us. The harder part is going to be able to sustain adoption over a long period of time. And for that to happen, we have to continue to partner with the businesses, work very closely with them to be able to articulate business value for adopting the cloud over the next 5 years, building the right business cases, building the right portfolio plans, and doing so. And while we do all of this, continue to expand the capabilities of the cloud. Ensure that we are offering rich technologies and ecosystems on the cloud, and introducing the right DevOps technologies in the process so that promotion management becomes a seamless experience for our developers. So in addition to that, I should also mention that I think one of the key challenges for us will be to ensure that we operationalize our environment to the point where it can be as reliable as how traditional infrastructure has been. So facets such as high availability, capacity management, performance management become very, very critical. And that happens to be our current focus, to ensure that all the non-functional aspects of infrastructure that apps have come to count on are protected and are solidly in place. So what I'd like to do actually is open it up to questions after Jonathan asked me a few questions. So I wanted to get through the presentation quickly and answer some questions from the audience once Jonathan polls me. So that's the short review, and then we'll go into Q&A.
Sure. And Nadi, are we doing break after this, or what's the?
There's a break after that, and we also updated the schedule.
Okay. Yeah.
Schedule. You see that on the OpenStack as well.
Sure. Thanks. So you mentioned cloud first, and this was something that I've talked to a couple of your colleagues about how you have implemented that. Can you tell me a little bit more about what the cloud-first policy inside TD Bank means for developers and applications?
Sure. I think it's really part of a larger transformation program across a variety of different capabilities at the bank, and cloud being one of them. So we have support from the very senior-most executive levels that the imperatives for the business is to be able to adopt agility. We have to be able to release critical business applications to market very, very quickly. So without cloud and DevOps, that it is simply not possible. So that's the driver, and all of the CIOs have agreed to that. So there is a top-down commitment, and I think all of the developers naturally embrace this. So cloud first is not so difficult as long as the cloud actually works.
Right.
And I think the reason why we are able to do the policy is because we have executed in a short period of time, rapidly executing with the right talent in place. So the easiest way to generate change is to do it right, is to build a solution right, and the capability naturally attracts the development talent. So I think we have top-down commitment from the executive team, and the capability is very attractive. So this allows us to do cloud first, which is in many places a hard thing to do.
Yeah. So what happens if I'm a developer and I want a server I can hug? What happens inside a TD Bank?
Yeah, well, they're not allowed to hug servers anymore. So in fact, they can't even have a IP anymore attached to their server, right? I think what we have done is, in addition to the coolness of the product, we've enforced a lot of strict controls. Mm-hmm. And part of those controls is you don't get to choose whether you go to the cloud or not. You simply don't. That decision is made for them using the right criteria, basically.
Right.
And I think from my experience, the developers are eager. They're ready to embrace the change. Now, there are occasions where there is a little bit of conflict in that process, but nothing that we can't manage through. So it isn't a significant issue at this point.
Yeah.
What becomes a more significant issue is developers want automated infrastructure, but they may not be ready to automate their application builds, right? And our solution is you don't install anything manually in our cloud. You have to automate every single piece. The idea is immutable infrastructure, and to truly get the value of being able to deploy at any point in time, at the click of a button, the whole stack has to be automated. And developers find it challenging to be able to invest the time and automate their application builds, the DevOps piece. That's where we've encountered some potential resistance and, if you will, learning curve issues.
Right, okay. Are there any questions from any of you that we can, yes, right here at the front.
My question is about the open standards and the OpenStack. So you choose to use Tosca in your solution. So what is the role and what is the importance of open standards, which is open source, like OpenStack, which doesn't really respect any standards except its own APIs?
Right. That's a good question. So I think a few different parts to that question, right? In terms of open source, it's not just OpenStack in our portfolio. We've embraced other forms of mature open source technologies, such as lightweight middleware and database containers. The role of Tosca is predominantly portability. So the ability to create an automation process, an orchestration process, that could be deployed onto any kind of cloud endpoint, between our off-prem cloud or on-prem cloud, maybe ESX as a hypervisor, maybe Amazon Web Services. So the portability of your blueprint, if you will, is a key dimension there, right? And with regards to OpenStack, I think we are operating in a managed services relationship. So really, Rackspace manages that for us, right? And the key there was to be able to ensure that the driver there was an architecture where we had flexibility. If you go with other hypervisors or other infrastructure management tools, your northbound connections are closed because it's driven by the commercial obligations of that vendor. And your southbound integrations are also, in many cases, limited. With OpenStack, both northbound, southbound, and lateral connectivity becomes a lot more open. You can choose from a more diverse set of products. I can choose from multiple cloud management platforms when I go with OpenStack. I can't do that if I went with a proprietary infrastructure management tool. So it's the center of the system that gives you freedom around the rest of your cloud architecture. That's the beauty of OpenStack.
Okay, thank you. What else? Any other questions? Don't be shy.
I forgot to mention we're hiring as well, so just needed to say that.
Oh, okay. So there was, yes.
There's a question here.
So information security, any improvements that you've needed to make or things that you would?
Absolutely. I think obviously as being a financial services provider, that's very critical to us. So actually the cloud has actually helped us in many ways improve the security model. A small example of that is we've increased the layers of zoning and separation in our DMZ using some of the logical separation capabilities, right, without necessarily having to compromise on the efficiency of our cloud, right? So that's an example where we've been able to implement greater degrees of logical multi-tenancy without being able to duplicate our infrastructure and our cloud management platform across our network.
Okay. Yeah, Florian. And this was the last.
On that same thing, how do you ensure things like PCI DSS and SOC compliance?
Yeah, very, very critical in terms of driving. So PCI compliance is a very important topic. And what we managed to do is to ensure that we create the right zoning model to have a separation of workloads. And we have had to create a PCI compliant data zone in the cloud, basically, right? That's segregated from the rest of the environment. And and also ask our application teams to ensure that they wrote their applications to be PCI compliant. So our cloud, we say, is PCI ready. It embraces all the minimum requirements in terms of encryption at rest. It provides a mechanism for applications to encrypt data that's in transit. It ensures that all the minimal security controls are present in the infrastructure. So we've had to, that's a given in our organization. We don't have a choice but to ensure that we have the highest level of conformance to PCI and SOX.
Very good question. How would you measure the percent of applications that can be cloudable and those that can't? Because
That's a very good question. I think so the question is, what percent of our applications are cloud, if you will, cloud native or not? The majority of them are probably not cloud native today. And I think this is a big challenge, because to tell your application team, please rewrite your application when they have other business priorities is a hard thing to do, right? So we've had, by virtue of embracing things like database clustering, WebSphere clustering, we have allowed for some of the old style applications to also find a home. And hopefully give them an approach where some applications can make minimal changes, and other applications, if they're willing, can make greater changes. So it's a path where you support diversity in the application architecture. And we are starting the process of actually coaching and educating our application teams and giving them the right incentives to why they should transform their applications. That's a long process. There's no easy answer there, right? But we have to be flexible to start with, which we have decided to be, with some boundaries, if you will.